Hello everyone, in this video we are going to see about the binary trees. We know that binary tree is a hierarchical data structure, and as the name implies, binary has two branches, left and right. Let us see the definition of binary tree. A binary tree node consists of the following parts: data pointed to the left child and pointed to the right child. We have the binary tree has two children, left child and the right child. So how to define? A binary tree is a data structure, is a tree data structure in which each node has at most two children. That means the children may be 0, 1 or 2. That is at most two children, which are referred as to the left child and the right child. So this is the diagram of this binary tree. You can see here 1 is the root and 2 is the left tree and 3 is the right tree, and for 2 left is right, 4 and 5 is the right tree, and likewise the subtree goes. And here you can see for 6 there is no left tree, only the right tree is here, and for 7 only left tree is here, right tree is not here, and these are called terminals. 8, 9, 10, 11, 13 and 14 are terminals. That means it has no children, they have no children. For these nodes, they are called the terminal nodes or the end nodes. So here these end nodes have 0 children and these have 1 child, these two nodes, and the nodes 5, 4, 2, 3 and 1 have 2 children. So the number of children may be 0, 1 or 2. Let us see how the binary tree is represented in memory, both in using the linked list as well as using the arrays. Okay, so binary trees in linked representation are stored in the memory as linked list. These lists have nodes that aren't stored at adjacent or neighboring memory locations. They are linked to each other to the through the parent-child relationship associated with the trees. Okay, so let us see how it is given in the form of an array and a linked list in the diagram. First, let us see the array representation. So here we can see the example of this tree is taken. Here the root node is 66, which is the top one, and this has two children, 50 and 21. They are the left and the right child. Okay, now how it is stored in the memory? Initially the root node is stored in the first location, and then next the left tree and then the right tree. So for 66, left is 50 and 21 is the right tree, so it is stored in the third location. Okay, after that next space the next node starts, which is 94, and then for 94 the children are 47 and 18. They are stored in 8 and 9 locations. So how to calculate these locations? Let us see the formula, how it is stored. Index of parent is equal to index of child node by 2. Okay, so here the index of child node, for example, this child node is 2 and 2 by 2 is 1, which is the parent node. The integer value, we have to take the round off value. Okay, so index of parent is, suppose if you want to see the parent of this node 21. Okay, so the index of this node is 3 and 3 by 2 is 1.5, but we are taking only the integer portion, so 1. So for both 50 and 21 we are getting the answer as 1, as 1 is the parent of 50 and 21. Okay, so then how to get the index of the left child and the right child? So the formula goes like this: index of left child is equal to 2 into index of parent. For example, if I want to find the index of this 47, we have to find the index of 94. The index of 94, which is the parent, is 4 and 4 2s are 8. So the left child of this node 94 is stored in 2 into index of parent. That means 2 into 4, which is 8. Then how to find the right index? Index of right child is equal to 2 into index of parent plus 1. For example, if I want to find out the index of this node 75. So how to get the node? The parent of this node is 21, which is the third location. So into 2 plus 1, right child, the index of right child is equal to 2 into index of parent plus 1. So for this 75, the index is parent index is 3 into 2 is 6 plus 1 is 7. So the right child of 21 is stored in the 7th location. So likewise, given any number of branches in the binary tree, we can able to find out the position of the or the index of the parent as well as the left child and the right child using these formulas. So this particular array, that is the address is stored in an array form like this. So we are having the value stored in 50, then 2 it is 0, then for 3 it is 21. After that 94 comes in the fourth index, it is stored, and now 5 and 6 are unoccupied. Okay, because you can see here there is no right child for 2, which should be in 5th location. Also there is no left child for 21, which is the 6th location. So 5 and 6 are empty, means they are the spaces for the some child node of the parent node. Okay, then 7 is the position 75 is stored, and then 8 and 9 has the value 47 and 18, which is the children of 94. So 94 is in the 4th location. 4 into 2 is 8, so 47 comes in the 8th location, and 4 into 2 plus 1 is 9, which is 9th location. The right side of the 94, which is 18, is stored. Okay, so this is how the memory representation is done using the array concept. Now let us see how the same is stored in the linked representation. So as we know that linked representation has two fields, the data field and the address field. Now in the case of binary tree, we are using the node which has 3 fields. What are they? Node, left and the right. Okay, so now here this is the root node, which is 66, and then to the left you can see here this is the left link. Okay, left link from this 50 is stored, and it has no right child, so it is given as a null pointer into, and then for this 50 it has left child, so this left pointer is extended to indicate the node 94, and here this 94 has both left and the right child children. So from the left link the value of 45 is stored, and from the right link the value of 18 is stored, which is the right child of 94. Now we can see here this node 45 has no left child and no right child. It is the terminal node. So both the left and the right node are marked as null value. Same way for 94 the right child is 18, and this is also the terminal node. It has no left and the right child, so it is given as an into mark, which is a null pointer. Then coming to this location of 66, 21 is the right child, and this 21 has left. There is no left child, but there is a right child. So left is marked as empty and right is given an arrow to the next child, and it goes to 75. 75 has no left and the right children, so it is the end of the node, which is the terminal node. So this marker which is present in the left child and the right child field will indicate whether the particular node has left child or right child or no child. Okay, so accordingly this is the representation using the linked representation for a binary tree. And again there is only 2 branches. There may be 0, 1 or 2 branches, as in the case we have seen in the normal tree. This is the linked representation. So this is how in memory both the array and the linked list helps to store the binary tree. Hope it is easy to follow, and thanks for watching.